All right, picking up the study guide, not from this slide. We got to jump forward a little bit. We're on number 7. All the way to number 7. There we go. Okay, so if two lines are parallel, their slopes are equal or the same. If two lines are perpendicular, their slopes are opposite sine reciprocals. Or you could say they are negative reciprocals, either way. Okay, and if two lines are perpendicular, the product of their slopes is -1. On to number 8, change the equation into vertex form. Keep in mind that this number I changed from the original study guide, so please change yours as well. All right, number in front of x squared is not a 1, so I got to get rid of it. Since it's a 2, divide everything by 2. I get y over 2 equals x squared minus 4x. I'm not sure what happened there. See if we can fix that. Minus 4x and then minus 10. Once the number is fixed in front of x squared, then we're going to add 10 to both sides, move that number over. And when we do that, that's going to get rid of the number on the right. We're ready to complete the square. So I'm going to set that up. Y over 2 plus 10 plus blank equals x squared minus 4x plus blank. Take the number in front of the x and divide it by 2. I get -2, square it, and I'm adding 4 to both sides. That is the completing the square process. Then we take what we have here. All of this on the right is supposed to factor to parentheses squared. We steal this number right here, put it in parentheses with the x. On this side, combine like terms. So I have y over 2 plus 14. Then I want to solve for y. So subtract 14 from both sides. I get y over 2 equals x minus 2 parentheses squared minus 14. Then to get rid of the y over 2 or y divided by 2, I do the opposite and multiply. And make sure to do that to both sides. On the left, put a 1 under the 2, cancel, we get y. On the right, the 2 has to distribute, which means drop it in front of the parentheses, and then also multiply by the 14. So 2, x minus 2, parentheses squared, 2 times -14, -28. Onwards. What do you need to show? To prove that a shape is a right triangle? So 2 different options here. Uh-oh, what happened? Hold on a second, guys. Okay, there we go. So what do we need to show to prove a shape is a right triangle? We have 2 options. The first one is that we can show, I can't write, dear heaven, let me try this. Let's try this again. Okay, show, apparently not. Show that Pythagorean theorem is true. That's one option. Our second option has to do with the fact that it's a right, well, both of these are because it's a right triangle, but one specifically with the right angle business. So the second option is that one where we say, okay, if we show that 2 sides are perpendicular, the perpendicular implies that we have a right angle. So those are your 2 options. All right, a parabola has a focus at 2, 5. This one I believe I changed from the original, so make sure to update that on your study guide. And a directrix of y equals 1, write the equation of the parabola. So I'm going to go ahead and graph 2, 5. That's my focus, and then my directrix is at 1. So here's a 1 on the y-axis, and then I'm just going to create my directrix as a nice dashed horizontal line. And from our notes, and I don't know what page that was on, somewhere in the notes on parabolas, we talked about the fact that the vertex, see if I can look it up for you really quick, the vertex is halfway between the focus and the directrix. So using that information, we look for the halfway point. That would be on page 192. So check out page 192. The vertex is halfway between the focus and directrix. So halfway between would be here. There's my vertex, since this distance is equal to this distance. And don't forget, this one up here was our focus. There we go. And from there, now I have the vertex. Sorry, I didn't mention this, but it is also in that same lesson on page 194, though. I can write this down, page 194. We talked about what we need when we're trying to write the equation. We need the vertex at h and k, which we just found, and we need the a value. So to find the a value, we're going to do 1 over 4p. So there's a. In order to find a, I'm going to need p. P happens to be this distance right here that we have in our picture. And in this case, it is a whole 2 units long. So 1 over 4 times 2. Again, that p is the distance from the vertex to the focus. That's your p. And when I simplify my equation, I get 1/8. Then to write out the equation in vertex form, y equals 1/8. X minus, where did we go for our center? Oh, I didn't write it out. Our vertex here is at 2, 3. So x minus 2 squared plus 3. Remember, h does the opposite of what it appears. All right, that's it. On to the next one. Number 11, a parabola is graphed on the coordinate plane below. The focus and directrix of the parabola are graphed and labeled on the coordinate plane. We're supposed to write the equation. So again, we're going to need the vertex at h and k, and we're also going to need a. So for the vertex, that happens to be given to us this time. We just got to label the point, -3, 2. Then the a value we're going to find with that same equation, 1 over 4p. In order to do that, we need p, which again is that distance from the vertex to the focus. That f up here means focus. And so if I figure that out, that is p equals 4. 4 units from one to the next. All right, so a equals 1 over 4 times 4. I get a equals 1 over 16. And so then to the equation, y equals 1 over 16, x plus 3 this time. Remember, h does the opposite, and then plus 2. Then we move on to the short answer part of the test. So for this, it gives you some information at the top, and it says determine the slopes of A, B, and CD. So first of all, the slope formula, y2 minus y1 over x2 minus x1. For A, I'm going to call this x1, y1, and B, x2, y2, and go right to it. So m equals 3 minus 8 over 6 minus 4. I get -5 over 2. Can't reduce it, can't divide it into a whole number, so I leave it. On to CD. So this one, I'll call it x1, y1, x2, y2, and here we go. M equals -5 minus 3 over 5 minus 1. I get -8 over 4. This one I can reduce down to -2. Then the part B says, can segments AB and CD be 2 opposite sides of a parallelogram? Well, first of all, if they're going to be opposite sides of a parallelogram, that means that the sides are parallel for opposite sides of a parallelogram. And parallel means that the slopes are equal. So if I compare my 2 slopes, I see they are not equal, therefore no, since their slopes are not equal. So I have no, since their slopes are not equal and they are not parallel, the sides cannot be 2 opposite sides. Sorry, can't spell opposite there. Of a parallelogram. So there you go.